So the next speaker is Joris van der Schot, who will continue on a similar subject, or not?
Right. On the origin of eVs. So before we start, I'm afraid that dinner didn't really agree with me yesterday, despite the excellent company. So I will start a little bit slowly and hope that somewhere along the way the adrenaline kicks in, and try to avoid the proverbial collapse of any wave function. My usual unit of energy in my day job, I'm ashamed to admit, is the barrel of oil. I've recently switched to the megawatt hour, but the electron volts, the eVs, are an evening and weekend free time activity for me. But they are, of course, the units of energy that are particularly helpful for the study of the effect that brings us all together here, the anomalous heat effect. Now, if you see a large bird on my opening slide, I reassure you we will not dive into biology, but the arc of my presentation will lead us to the proposal of an experiment, and that experiment, when realized, might lead to the discovery of an exotic new species, be it not a biological one, but an atomic one. The black swan, of course, also represents a highly unexpected event with huge consequences for society, which is why I think it is so relevant to the anomalous heat effect that we discuss. It will change the civilization on this planet and potentially elsewhere. Of course, we all love black swans, but we sometimes forget that to find tomorrow's black swan, we have to look at today's ugly ducklings. And so the ugly duckling, I think, would make an excellent mascot for this society. But the place was unfortunately already taken by a rather more sexy bird, the mythological phoenix, who rises from her own ashes. You can see this logo represented in our society's logo on the bottom left. On the bottom left there. And if you have very good eyes, you can read the motto, Ardet nec consumitur. She burns, but is not consumed. Now, I actually take some issue with that, because my understanding of the experimental side of things is that we don't generally take the ashes of the previous experiment to run the new one. No, you need some fresh fuel. So it may seem like nothing is consumed, but actually a little bit is consumed. So let me just quickly fix that and make it, she burns, but is almost not consumed. And the analysis of the ashes of that phoenix, those ashes that are so small in quantity that they lead us to conclude that we have an anomalous heat effect in the first place, because it excludes any chemical origin of the heat, leads me to a very simple dichotomy that I would like to submit to you this morning. Are we looking at a nuclear effect, or are we perhaps looking at a non-nuclear effect, or both? Now, in business, we always like to use these 2x2 matrices. It makes it look a little bit more professional. I suspect the majority of you in this room, at least that was the tendency of the presentations we've seen so far, finds themselves in the upper left corner. You work on the basis that we are studying an anomalous heat effect of nuclear origin. And there is a lot of experimental evidence for that, including some of which that has been presented over the past few days. But there are other researchers in the bottom right of this diagram who work on the assumption that the anomalous heat that they find is of non-nuclear origin. Now that field is quite diverse, but I would like to zoom in today on only one example, which is Randall Mills of brilliant light power. He believes, and most of you will know his theory, that the origin of the heat is due to a below ground state of the hydrogen atom that he calls hydrinos. Now, for the other two quadrants, of course, most people outside of this room are in the bottom left. They don't think there's any heat at all. But the one I would just like to discuss with you very briefly is the top right quadrant. What if both effects are real? In that case, I submit to you that these effects cannot be independent. Each of them independently is unlikely. If both exist independently, that would be unlikely squared. Impossible in my book. I have an open mind, but I do not believe that there are two different effects. So if we see two effects, they are necessarily related in my book. And the logical connection, in my perception at least, would be that the non-nuclear effect precedes the nuclear effect. In this case, for example, hydrino might be a necessary precondition to trigger subsequent nuclear reactions. This is also, for example, proposed by Ed Storms at some point. So, in my quest to understand the origin of eVs, it seemed logical to me to first start in that bottom right corner and analyze and potentially discard that option before moving into the second step, which might be a nuclear effect. So what evidence do we have that there may be something in that bottom right corner? And I will focus on Mills, but he's not the only researcher in that field. Other people do talk about condensed forms of hydrogen in one form or another. Just a reminder, Mills is of course one of the very early participants in this field, even though he rarely shows himself at these conferences and has taken a different route. But he did very early on propose his theory as an explanation for the anomalous heat effect. More recently, he has moved to using liquid electrodes, which I think reaffirms the conclusion that Lutz was also suggesting, which is that a metal lattice is unlikely to be essential to create anomalous heat effects, because there is no lattice in this case. But the main point of evidence is more recent, and it discusses an analysis that was done at my alma mater, the Delft University of Technology, by Professor Hagen. And this was done completely independently. The reactor was run in America by Randall Mills. He took the ashes, sent them across the Atlantic, and Professor Hagen analyzed those ashes with EPR spectroscopy. Now, both scientists did do the write-up collectively, so of course the paper is work of both scientists, is not completely, is interdependent, so to speak. But nevertheless, this paper concludes that the evidence provides compelling evidence for the existence of molecular hydrino, as well as lending plausibility to the electron model in GUT-CP, which is Mills' theory of nature. Now, I find this intriguing, yet not entirely convincing. Of course, it's one data point. The authors do invite others to follow and to also measure those same masses. But what I wanted to do is see if I could devise another experiment, a kind of follow-up experiment that would strengthen both of these conclusions with a focus on the plausibility of the electron model. And so for the rest of this talk, I will walk you through this Gedanken experiment. Mill's theory is of a breathtaking ambition, but we will not treat it here. We will only look at the keystone of his theory, which is of course incomplete. I fully recognize that. We will only look at the keystone, which is the model of the electron. It's literally in the first couple of pages of his 2,000 or so pages in total. Now, you may say, come on, Joris, we're at the start of the 21st century. We've known the electron for a very long time. Don't we know what an electron is? Well, I think some scientists in their lifetime were not satisfied by the dominant theory of explaining the electron and other phenomena at the atomic level. And this certain, I'm trying to find the word, unease seems to still linger among certain physicists, such as Sean Carroll here. And of course, we are talking there about the interpretation of quantum mechanics, not the calculations of quantum mechanics. And I also found this article in Quantum Magazine quite interesting, which asked a very basic question: what is a particle? And by extension, what is an electron? And there are numerous different results or propositions. So it doesn't strike me as outlandish to propose another one. I will skip this and cut right to the chase, to the result of Mill's electron, which you find represented here. What Mills proposes is to go back to the early days of atomic physics and address the radiation, the radiation problem of the electron. We know electrons, when they are accelerated on a macro scale, they radiate out energy. Why doesn't the same thing happen within the atom? And Mills is inspired by one of his professors at MIT, who happens to develop a paper on the radiation of point charges, or from point charges. Mills runs with that, inverts the logic, and tries to define a law of non-radiation, or the conditions of non-radiation, and then apply that to a model of the electron. He is not the first to have done that. In the 60s, Gödecke had already hinted at the possibility of creating an extended electron model that would not have this radiation problem. And Mills is the one to nail it and to find this model that you see here, which is surprisingly simple. It is a two-dimensional membrane around the nucleus, which you can visualize as a soap bubble around a grain of salt. Do not be deceived by its simplicity. There is a lot of complexity within the membrane, within the two dimensions of the membrane. The electric currents are very complex, and Mills uses all the degrees of freedom that he has in these two dimensions to make the electron fit all the observed parameters in the hydrogen atom and elsewhere, including fine structure, hyperfine structure, etc. For my argument, we only need the geometry of the electron, which we have here. So I'm in luck because I would be unable to explain the mathematics behind the actual surface. There are two things more we do need to know about that geometry, however. The first one is the bubble expands and shrinks with quantum jumps, just like the regular atoms that you are used to. The unusual thing is what I mentioned earlier, that below the ground state, Mills hypothesizes that there exist below fractional quantum states that are physically smaller. The electron bubble collapses much closer to the nucleus. And this is associated with large amounts of energy, quickly into the hundreds and thousands of electron volts, which could be an explanation for the anomalous heat effect, of course, the non-nuclear one. The second thing we need to know is that multiple electrons organize into concentric shells around a nucleus. Now, if I put that against the more traditional model of electrons, the probability cloud concept that was proposed by Born, in some sense, Mills' radial probability density function is a Dirac delta. That is not a spin, that's a Dirac delta function. All of the electron is just at a single radius in Mills' model, but the electron is all around. Now, this radius can change up and down with quantum jumps, and it can go to this lower hydrino level. Now, this picture, this image, it kind of got under my skin, I'll be honest, and I kept wondering, could it really be that for all this time, electrons have been two-dimensional particles? Because Plato teaches us that when we see two-dimensional shadows in a cave, the underlying reality we have to interpret is actually three-dimensional. And I was wondering, could it be that that is simply not the right conclusion for elementary particles? Maybe when we see two-dimensional shadows, well, it's because the original is also two-dimensional. And from Plato's cavern to the Atlas cavern at CERN, even the most advanced detectors reflect mere shadows of reality. Or, as someone put it on that Quantum Magazine article, particles are simply clicks in detectors. And so, and Heisenberg would agree, I think. Not Schrödinger, but Heisenberg would. So this kept me wondering, and I thought, is there not a way that we could place a detector inside an atom? Now, atoms are, of course, very small. Bless you. And again, I found inspiration at CERN, where they have an antimatter factory. And it occurred to me that perhaps we could use antimatter as an arbiter of reality. And the idea is really simple. If we can create a bound state of an electron and an anti-electron in an atom, then if those electrons are really like a probability cloud, they are bound to overlap and at some point annihilate. In fact, that's what we see happening most of the time. On the other hand, if electrons are really, like Mills says, well, then there's no reason they should overlap, and there's no reason they should annihilate, as long as their orbits are stable. So how could we go about that? Well, the trick is to start with the electron configuration of lithium. Lithium has 3 electrons. 2 of those pair up in a first electron shell, and the third one spawns a new shell quite some distance away from the first 2. So we can use that idea and then swap out that outer electron for an anti-electron, and we're done. Now, You can't do that with lithium. You have to start with hydrogen. You add 2 electrons to hydrogen, create the hydride ion, and then that negative ion can indeed attract a positron. Unfortunately, that composition of matter is not stable. And the reason it isn't, and this has been tried, and there's experimental evidence for this, and the reason it's not stable is most easily explained through electron affinity. So positron, the positron has an electron affinity of 6.8 electron volts. And that is much higher than the whole of the periodic table of neutral elements. So if you try and add an electron to any of those neutral elements to get a negative ion, well, that additional electron will always end up being pulled away by the positron more strongly and end up annihilating. So, nice idea, but it doesn't work. However, serendipity is a thing. So I could not mount my Gedanken experiment with just Mill's assumption about the two-dimensionality of electrons. But his theory holds another key assumption, which is the existence of hydrinos that we just discussed. And when you think about it, hydrinos are really tightly bound forms of hydrogen. In other words, they have a much higher electron affinity than normal hydrogen. And Mills calculates these in his theory. I didn't invent a thing. He calculates, for example, for the 1/4 state, there's a whole series of hydrino states, fractional quantum states. The 1/4 level, that particular hydrino has an electron affinity of 11.2 electron volts, which is much higher than a positron. And therefore, in the hydrino atom, according to Mill's model, those two inner electrons should be much closer to the nucleus and much more tightly bound, and it's therefore much more likely that the positron, when you add it on, will form a stable orbit sphere, as Mills calls them, around, and stay in orbit indefinitely. Now, and that would be quite something, because today all attempts at creating atoms or molecules of matter and antimatter together always yield compositions that are not stable in the physical sense, i.e. they always end up annihilating, generally on the timescale of nanoseconds. Now, how could we physically make these? Well, they have a wonderful Antihydrogen Trap at CERN, where they feed in positrons from one side and antiprotons, decelerated antiprotons from the other side. Those two get to meet, form completely stable antihydrogen atoms, and the magnetic trap avoids these atoms touching the walls, because as soon as they touch the walls, of course, they end up annihilating. Now, what I propose is that, perhaps we might be able to swap out those antiprotons and replace them with hydrinohydrides, do the same thing, and then just look at the annihilation signals coming out of such a trap. It doesn't have to be at CERN. I'm sure we can do that in a simpler way elsewhere. And just look at the resulting annihilation signals. If all of the annihilation arrives within a couple of nanoseconds, then we know that this particular hypothesis is just cannot be confirmed. However, if we see a delay into the millisecond, second, or even kilosecond range, then we know for sure that these positrons have found some stable parking spot within that magnetic bottle, and the only reasonable conclusion to draw is that they have formed a stable composition of matter, a stable atom with a hydrinohydride. So in summary, my reasoning, if we backtrack, I propose if we can somehow measure delayed annihilation from Mill's hydrated ashes plus anti-electrons, then that would provide further evidence for the existence of hydrino and for the two-dimensional nature of electrons. In turn, this brings us back to our anomalous heat effect. This is then, of course, the origin of non-nuclear eVs and a likely, highly likely precondition for any nuclear eVs. Now, finally, because positronium hydrinohydride is quite a mouthful, I thought it would be appropriate to give a name to this novel exotic atom. And given the theme of this workshop, which is held in memory of Bill Collis, I propose to name this hypothetical exotic neutral atom Collisium. It's perhaps not quite the exotic neutral particle that Bill always philosophized about, but it's probably as close as we can get. And as a very last thing, I wouldn't want to leave you without at least mentioning anti-Collisium, where the antimatter is in the center and it is encapsulated by a normal electron. Now, I don't expect us to be able to synthesize this in my lifetime, but if future generations do, this would of course be a wonderful way to store antimatter. And it would also give a whole new meaning to the word electron volt. Thank you very much.
Thanks for your talk. My name is Chris Scott. My only question is, without knowing the details of Mill's theory, do you know what the main detractors are from a mainstream perspective?
Yeah, I think it's just pretty too revolutionary for most people, understandably so. And it's just a matter of, for Mills to keep building on evidence for his theory and slowly get either acceptance or not. He himself is working on both the experimental and the theoretical side. I'd say within that large theory, you are bound to find many, many elements that are unconventional, and maybe some of them have been developed more in an intuitive way than kind of fully worked out. There's only so much one man can do. But I think the main objection is simply the existence of this fractional quantum levels.
This morning's session is turning to be a very special one, doesn't it?
Okay, I have question too.
Okay. Maybe. Sorry. So the concept of the very strongly bound electrons in atoms is a very long, this very old concept already. So it's not necessary to have two-dimensional electron. This main problem was, to include magnetic moment interaction on the relativistic level. So there are some predictions that this kind of interaction is so strong, if you are coming down to very close to the nucleus, these magnetic moments are very strong, and then this interaction can contribute to the binding of the electron very close to the nucleus. But my problem is something else. If you would have this kind of structure, you should observe transition between usual hydrogen and this strongly bound hydrogen. So it is very easy to check it. You should have a large number of hydrogen atoms and put X-ray detector, and then you should see something. This is one point. Another point is also a Gedanken experiment. You should observe something also if you are looking to our universe, because there is a lot of hydrogen there, and we should see this kind of emission as well. What is your answer on that?
Yes, thank you for your comments and question. Yeah, I'm not sure if I'm the most qualified person to speak for Randall Mills' theory, but I can try and repeat the general argument that he uses, which is that the transition is not spontaneous. You need certain conditions to trigger that transition. So just confining hydrogen is probably not enough. You need, well, one of its reactors to make that happen. But there are a lot of spectroscopic pieces of work that have also been done on that front. And one of them I may have here, which is by Professor Conrads some time ago, where they really looked more at the spectral signature, indeed. As for the occurrence in the universe, yeah, Mills' argument is, look, these hydrinos are very small. Once they have formed, they are very small. The most abundant element in the universe is hydrogen. Maybe what has happened in the universe is that these hydrinos have indeed formed. It's just that we can't see that matter, because when they are so small, these atoms are so tightly bound that they no longer interact with light. In short, Mills proposes that the identity of hydrino is the dark matter that we are looking for in the universe. There's all kinds of arguments against and for that, of course.
Another question. Yeah. I understand the logic that if you put hydrinos and positrons in a magnetic trap, you should expect different signals. But how do you make hydrinos? What's the recipe for that? So what's the operations to produce hydrinos?
Yeah, so I can only answer partly for that, but Mills is producing reactors where he proposes to make these hydrinos, and we are measuring them.
Okay, so it's available somewhere to read.
Yeah. Oh, yeah. There's good. Lots of yeah.
Thank you.
So my comments will be acid for walls. Generally speaking, the explanation of transmutations called nuclear fusion, low energy nuclear reactions must be based on the existing establishment in physics. This kind of theory, which you mentioned here, is beautiful. However, if we use this theory, or this theoretical approach, our actually cold fusion nuclear community will face significant trouble, which to be understood. No, I'm positive. Okay? Because it goes out of the existing establishment in physics. Is that the things?
Yes, it does.
Yes, it is.
Sure it does.
Yeah, sure, it's a risk. I think there are many proposals that go a little bit outside of established physics. And this is one of them.
A last comment, and we have to go because we are running late.
I'd just like to mention, Joris, thank you very much, by the way. As a young man, I was introduced to Sir William Penny, who at that time was heading up the UK's atomic weapons programme. And we and a couple of others got into a discussion, and I said to him, but Sir William, what is an electron? And he looked at me and down his nose and said, well, dear boy, he said, it's a freaking electron. I don't care about what colour its shoes are or what kind of tie it wears. I just care about what it does. There. Sorry.
Well, human nature.
Quick question. Why is Mills only talking about hydrogen? His theory could be applied to all elements. So I would expect shrunken lithium, shrunken everything. This is one thing that's absolutely unclear to me. And the other thing that strikes me is that I studied almost all his experiments with great excitement, not because I'm a believer in hydrogenos, but because all the experiments seem to match the plasma experiments that we try to do. So it has resemblance to experiments that are LENR. So maybe there is a connection stronger than we think.
Yeah, thank you.
No, the first one was a question. Why is it only applying to hydrogen?
Sorry, I have no idea, but I can imagine that hydrogen, has different characteristics from all the other elements in the periodic table, right?
Hi, I wanted to ask a question, if you have time. Professor Jakes, can I ask a question?
No, but do it away.
Go. Go. Okay, so I am Ankit. I wanted to ask a question. So we've been following his experiments for the past 3 years, and he started with electrolysis, and then he moved on to roller mills, and then later he moved on to a spot welder kind of thing to produce his hydrogen products. I basically do the experiment, and then I believe if whatever people's claims are. So I just wanted to know, do you have any idea what logical framework he uses to decide the way he is going to produce his hydrogen products? As for example, he started from electrolysis, that was fine, and then he moved on to roller mills, and then he moved on to a spot welder.
Yeah.
It's very absurd. You understand my question?
Yeah, I think there's some logic to it. So Mills, he's quite an extraordinary theorist, I think. He may not be right, but he's quite extraordinary in many ways. But he's also quite a good engineer. And the problem he ran into is the same as we heard from Francesco, is his wires kept breaking, right? Because as you are seeking higher power levels, right, these electrodes, they tend to break. And therefore, at some point, he got to the higher power levels, the electrodes broke, so he mounted a couple of electrodes on these rotating discs to get, sparks. But then you have to replace them. And at some point, he had a quite, a brilliant idea, in my view, which is to say, okay, if these electrodes are going to break, I might as well use a liquid that's already broken. And that's why he started with these liquid electrodes. The reaction keeps working. The droplets are ejected to the walls and reassemble at the bottom for a new cycle.
Okay. Thank you very much.
Thanks
but
for your kind response.